try that. Okay, experimental research. Again, I'm going to speak pretty quickly. Again, I only have 15 minutes. So the definition of experimental research entails, again, manipulating at least one independent variable, okay, and observing that effect on the dependent variable. Again, depending on the design, you can manipulate more than one, but you must manipulate at least one for it to be experimental research. So the purpose here is to, after that manipulation, to understand cause-effect relationships and really ultimately the effect of a treatment on a particular phenomenon that you're studying, for example, okay? So there's a process, obviously, like all research has a process. Select and define a problem, select your participants and your measuring instruments, prepare a research plan, execute the procedures, and then analyze the data and formulate conclusions. We've talked about already in the past what independent and dependent variables are. The aspect we haven't talked about as much as validity. So yeah, validity is very important in quantitative research. You're going to have two different types of validity, essentially. You're going to have internal and external validity. Just put it this way, internal validity are those things that are a little bit more controllable by the researcher, that you can sort of manipulate that control, or you can sort of have more control over that. External, you have less control over that. That may be a fight that happened, at school that morning, or, the weather, it's a hot day or a cold day. Those things researchers have less control over than the internal. So these are just examples here of independent and dependent variables, as you already have all mapped out a whole list of examples. So right, again, manipulation of at least one variable, we've talked about this. So two types of variables that need to be controlled. Participant variables, and this is when you're aiming for a homogeneous sample, right? And then you have to have the environmental variables as well. The environment of the school would have a lot to do as an environmental variable that needs to be controlled or needs to be understood. So these are threats to experimental validity. Particularly, you have statistical conclusion validity. Internal, we've talked about internal a little bit. Construct validity and external validity. So it's not, so threats to internal validity, you have history, right? Sort of the timing of a pre and a post, or, the pre, when it's given, the events that happen leading towards that event of, an exam where you're collecting data. Maturation, right? So if you're doing a pre and a post, how long do you wait before you give the post, right? The more you wait, the more different things can go wrong, but also you have to give it enough time for the subjects to be able to mature so you could see growth. Testing also, if you're doing a pre and a post, this happens a lot, that the pre has some effect on the post. If they remember what that pre was or what the answers were, they may be sort of recalling those memories to take a post test. Instrumentation, and also statistical regression. Differential selection of participants, as well. Mortality and attrition, right? That's when participants may drop out of the study. And selection, maturation, interaction. Threats to external validity, you'll have a pre-test treatment interaction where subjects respond differently to a treatment because they have been pre-tested, of course. I see that a lot in my own research. Multiple treatment interference. Multiple treatment interference, you have selection, treatment interaction, and specificity of variables. Threats to external validity, you have treatment diffusion as well. Occurs when there's different treatment groups that communicate and learn from each other and affect each other. So if you're taking an exam and you have some kids that come in, they take the exam and go to the playground, tell the kids what the exam was about, and then the other kids come in after, playtime, and that might have some effect on those results. Experimenter effects. The researcher may affect the study by who they are, how they behave, and their previous knowledge of that school, right? Do you connect with the kids? Do you not connect with the kids? How are you introduced? That type of thing. And then you have these reactive arrangements where this is related to how a study is conducted and the feelings, attitudes of the participants about, do they want to perform for you or not? Are you giving them pizza? or are you giving them candy, or are you not doing those things that they may want or are used to. So controlling for these extraneous variables, obviously randomization really for true experimental. That's key. That's the staple of true experimental research. Matching, the researcher attempting to find pairs of participants on similar variables. Comparing homogeneous groups or subgroups. Participants as their own control can serve as their own controls. And the analysis of covariance is another threat. So the group designs, okay? You obviously have the single variable design, which involves the manipulation of one variable, 3 different types, okay? Pre-experimental designs, true experimental designs, and quasi-experimental designs. As we talked about, this is key. Randomization is key in the true experimental, and these are, in education and schools. You're going to see a lot of these quasi-experimental designs where randomization is not possible. Factorial design, this is where you're getting down to more complex designs. Here, you may be manipulating more than one variable and then testing, obviously trying to control within that test, but you have a factorial design because you have 2 variables running and you're affecting one. You're having a treatment to affect one where the other one's running, and then you switch it up and you have a treatment to affect the second one to see what happens to the first one, okay? So the interaction of these is very important, and they affect one another. So this is just an overview of the pre-experimental designs. You have the one-shot case design where you may have the treatment. So this would be treatment here, and then you have, an exam, right? A test. Here you have, a test that established sort of baseline. Then you have the treatment, and then you have a post. So this is one group, pre-test, post-test design. Then you have the statistical group comparisons where you have 2 groups. You have a treatment for one group, a treatment for another. Perhaps they're different treatments, or perhaps they're the same treatment. And then you have a post-test or just an exam. We're not going to call that post-test because there was no pre. So this here gives you an overview of internal validity. Remember, these are the things you can control, okay? These are the things you can control. And then external are a little bit harder to control, all right? But these are the ones that you can control. So wherever you see plus, that means that the factor is controlled for, right? So this is good. A lot of things are controlled for here, but this one falls short in terms of history, maturation, and mortality, right? Because there is no pre-post. So the history, maturation, and mortality, you can't measure those. You don't know the effect of those because you only had essentially one exam. This one here, which would seem like it's a little bit more of a complex design, is going to control for a lot more. It's going to control for a lot less things, right? So it does control for maturation, but it doesn't control for history, maturation, testing, instrumentation, and regression. This one here would be, so obviously this one's optimal when you're controlling for a lot of things. This statistical group comparison does control for a lot of things, but it doesn't control for maturation because, again, there's no pre-post, selection, mortality, or selection interaction, okay? And all of these are pretty good designs in terms of controlling external variables, except this one group pretest design that doesn't control for the pretest treatment interaction, again, but this is sort of the overview here. Okay, so these are the pre-experimental. They don't do a very good job of controlling threats of validity, and should be avoided is sort of like an overview. I mean, sometimes you don't have a choice, but this is, there's better designs, obviously, but we're gonna look at those right now. So here, these are a little bit more complex design. These are true experimental. Remember, these are the optimal type of sort of designs, to be able to. So you have the pre-test, post-test control group design, which has, remember, randomization across all of these. Remember, this is key. Randomization is key. And a lot of these look very similar to the previous one, right? Other than this pre-test, post-test has, the pre-test, both of them, there's two groups, they're randomized, and both of them are going to have a pre and a post-test, and both of them are going to have the same or different treatment, but there's two treatments. The post-test only, this one has, this is the post-test right here. So you have treatment 1 and 2, there's different treatments. You have a control group, and this one's probably very, it depends. This one, there's different reasons for why you would have a pre-test and not a post-test, but nevertheless, these are different designs. And then you have the Solomon 4-group design. This is a real sort of robust, as you see here. There are absolutely no threats to validity. This is such an excellent design to be able to implement. Randomization, again, like the others, but you have 4 groups. And on 2 of them, you have a pre-test. On 2 of them, you do not have a pre-test. And then you have, so this one here, pre-test, post-test, this treatment. And here, all you have is the post-test, but the same treatment, okay? This one goes with this one, and this one goes with this one, so that you're able to affect the interaction, the pre-test interaction, right? That's why this is so key here, because it controls for that, because you're looking at the effect by removing the pre-test, okay? So these type of true experimental control for nearly all threats of internal and external validity through random assignment of participants to treatment groups, okay? Then you have the quasi-experimental, okay? Quasi-experimental, we said these are very common in the school. What's missing here is obviously, as you see, there's no randomization, but they look very similar to some of the other ones, except, so here is a non-equivalent control group where you have a pre-test and a post-test, and you have 2 different treatments, okay? And then on this one here, you have a time series design. These could be considered all pre, but I wouldn't call them pre. I would just call them, different points in time where you're collecting data to see growth over time. And then you have a treatment, and then you do the same thing. Usually this is the same, the same treatment, the same exam. And I'm sorry, not the same treatment, the same exam. And you'll see whether there's growth or not based on that treatment. Counterbalance design has 3 groups and 3 different treatments that you give. You give the treatment, and then you switch up the treatment for all the groups. And then on the last one, you switch up the treatment one more time so that group 1 gets treatment 1, then 2 and 3. Group 2 gets 3, 1, 2, and group 3 gets 2, 3, 1. And this is going to be able to control for almost all threats of validity, except the only one it doesn't control for is selection interaction, and on the external, pretest interaction, or also multiple interface interaction. It doesn't control for these things, but I would say it's still a pretty robust design. Okay. And this is when random assignment is impossible. Like if you're in a classroom and you can't test only some kids, you have to test all the kids. That's very common in a school setting. So this is an illustration of interaction or no interaction in a 2x2 factorial design. So we're looking at a factorial design. So IQ may be high and low. The method may be A and B. And so here you have 4 different things that you're looking at once here to understand their effect. And so here you would have no interaction where these lines do not cross over. This one's up here and this one's down here. Down here you're going to have the same thing, but over here there is interaction because these do cross over. Okay. So a factorial design is an elaboration of single variable experimental design that involves 2 or more independent variables, at least one of which is manipulated, and the non-manipulated variable becomes the control group.